Hello and welcome. Today, we're going to dig into a really classic thought experiment from the world of artificial intelligence. It's called the monkey and banana problem. Now, it sounds almost silly, right? But it's actually this brilliant way to understand how we can teach a computer to think, to actually solve a problem all on its own. So let's dive right in.
So, this is really the big question, isn't it? I mean, we all know computers are fantastic at following a list of instructions. But what do you do when you can't give it the list? How do you get a computer to figure out the steps for itself? That's the puzzle we're going to solve today.
All right, first things first, let's set the stage and introduce the actual problem that our computer and its little monkey sidekick are going to be up against. To you and me, the solution here is just obvious. You look at it for a second and you know, move the box, climb on the box, get the banana. Easy. But you have to remember, for a computer, this room is a complete blank slate. It knows nothing about monkeys or boxes or bananas or even gravity. It has to learn the entire world from absolute scratch. So, how do we even begin? Well, before the computer can solve anything, our very first job is to teach it how to see this little world we've created. We have to define its reality, one piece at a time. And the most fundamental concept here, the bedrock of this whole thing, is the idea of a state. Just think of it like a single snapshot, a freeze frame. It's a perfect description of everything in the puzzle at one precise moment in time. For our little room, any possible state can be described using just these four key facts. So for example, our starting state is this. The monkey's horizontal location is at the door, its vertical position is on the floor, the box's location is at the window, and the monkey's banana status is has not. That's our starting snapshot. Okay, so the computer can see the world as a series of these snapshots, these states. Great. But how does anything happen? How do we get from one snapshot to the next? Well, that's where we have to define the rules of the game. And this is a really crucial point. The world doesn't just change randomly. Nothing happens by magic. The only way to go from one state to another is for the monkey to perform a specific valid action, what we'll call a move. Every single move is a rule that tells the computer exactly how to transform a before state into an after state. Let's look at the first move, walk. The rule here is super simple. If the monkey is on the floor, it can walk from one spot to another. And notice what changes and what doesn't. The only thing that changes is the monkey's horizontal location. Its vertical position, where the box is, whether it has the banana, all of that stays exactly the same. Next up, we've got push. Now this one's a little trickier because it has a condition. The monkey has to be on the floor and at the same exact location as the box. If that's true, then it can push the box somewhere else. And in the after state, you can see both the monkey's and the box's locations have changed together. Then we have the climb move. And you can probably guess, this one also has a condition. The monkey has to be at the same location as the box. This move is special because it's the only one that changes the monkey's vertical position, flipping it from on floor to on box. And finally, here it is, the winning move, grasp. This one has the strictest rules of all. It's only possible if, and only if, the monkey is in the middle of the room, is on the box, and doesn't have the banana yet. If all of those things are true, this move makes the final, crucial change to the state. Has not becomes has. And that's it. Game over, we've won. Okay, let's just take a breath. We've given the computer all the building blocks. It knows what the world looks like. Those are the states. And it knows all the ways the world can change. Those are the moves. Now for the really cool part. Watching how it uses pure logic to put those pieces together and find a path to victory. Yeah, this is the million-dollar question, isn't it? The computer doesn't have a cheat sheet. It doesn't know the solution is walk, push, climb, grasp. It has to discover that sequence entirely on its own. So how in the world does it do that?
Well, the logic it uses is it's so elegant. It's really simple and incredibly powerful. It all boils down to just two rules. Rule one is the easy one. You can get the banana if the state you're in already says you have it. Duh. Goal met. But rule two, that's where the magic is. It says you can get the banana from where you are now if you can make a legal move to a new state, and from that new state you can get the banana. So the computer just keeps asking itself that same question over and over, creating a chain of logic until it finds a path that works.
And just by applying that simple two-part logic again and again and again, the program explores the possible paths until, bingo, it finds one that connects the start to the finish.
It discovers the solution all by itself. Start at the door, walk to the box, push the box to the middle, climb it, and finally grasp that banana. Goal achieved. But hang on, what happens when it makes a wrong turn? Because it will, right? It's not a psychic. It might try climbing the box while it's still over by the window. When it does that, it very quickly realizes, hey, there are no more moves I can make from here that will get me the banana. It's a dead end. So what does it do? It simply backtracks. It kind of shrugs, takes one step back to the state it was in before, and says, okay, that didn't work. Let's try a different move. No panic, just pure logical trial and error.
Now, this is super cool, but I promise you, this is not just about a virtual monkey getting a snack. The real power of this idea goes way, way beyond this simple puzzle. Let's zoom out for a second and look at the bigger picture. This whole approach, this entire way of solving the problem, is a little window into a really powerful style of programming called declarative programming. The big idea is that instead of telling the computer how to do something step by step by step, we just describe what the world is like and what we want to achieve. And that right there is the key takeaway. Think about it. We never wrote code that said, first walk, then push. We never gave it the answer. All we did was describe the world through states, define the rules of physics through moves, and then we set a goal. Any state where the monkey has the banana is a winning state. We describe the problem, and we let logic find the path. And that kind of leaves us with this final big thought. From figuring out the most efficient route for a fleet of delivery trucks to discovering new ways drugs might interact in the human body, what other massive, complex problems could we solve if we stopped trying to write out every single instruction and instead just got really, really good at describing the rules of the game?